بسم الله الرحمن الرحيم. Volume and flow measurement. These are some questions that you may be asked during the oral examination. First of all, the Benedict-Cross spirometer and the principle of the vitellograph. Of course, Benedict-Cross is used to perform the fixed principle, and the vitellograph is a portable apparatus. You may be asked why there is a small seal, water seal in the Benedict Ross, of course, to minimize the gas loss. Now we have what we call the dry gas meter. We will be illustrating it in the figures later on. It is the most domestic apparatus. The most important thing is the compact right respirometer. I will show you later how does it look like, and the electronic volume monitor. Of course, when I mention right respirometer, you could be asked about what is the functions of the slits. Of course, to assure a circle movements of air so that the van can rotate. What's disadvantage? I cannot take or preserve readings post instrumental use, and the calibration of it is inaccurate. So these are the drawbacks. But regarding the electronic volume monitor, I will show you later. The most important that there is no gear system, so that makes it more accurate. There is no drag of gears, but I'm afraid that it needs electricity, and it is a cumbersome apparatus. It cannot be portable being used. Of course, all these instruments, whenever you can see, must be corrected at standard temperature and pressure, because all the volumes are not corrected at that point. This is the importance among scientific workers. Now we come to the blood, the liquid volume measurement, and we have the dilution method. Of course, the dilution method means that I'm injecting a labeled RBC, suppose, in the circulation, and then I try to find its dilution, and then I can later on calculate the blood volume, and from drawing the hematocrit I can create the total blood volume. Of course, it's not accurate in shock patients because there is no even distribution of blood, and we must remember also how can we measure the extracellular fluid by labeled also albumin. The rotor meter is a very important item where you could be asked about. Whenever this bobbin elevates, the annual space around it increases, so the resistance decreases. This you may be asking, okay, why is the pressure above and below the bobbin is equal? Because the annual space facilitates or minimizes the pressure. Of course, the rotor meter, of course, it's liable to stick because the tube is not in a vertical position, or it may be affected by static electricity, or if it is in a very upper volume or lower volume, of course, it will stick. So there are many methods to avoid this static electricity. You could be asked. You ought to tell them that this inclined tubes are coated with special material that minimize the static electricity and also the sticking method. Of course, we have why do we have low and flow and high flow meters? Suppose option to minimize the defect or the mistakes regarding the values. The right peak flow meter, I'll show you later on. It also has a van, and this van rotates. This van is being supported by a special spring to keep the pressure, and as long as the van is being moving, circling, the annual space, or there is a space, will increase. This why we call it a constant pressure variable orifice, because the orifice is being increased whenever the van rotates. And of course, its pressure is maintained by this spring. You may be asked what is the normal peak flow of an adult. You can see from the figure what's the normal and what is the abnormal. The pneumotachograph is another method to measure the volume of a gas. It is made of a mesh. This mesh is large enough to maintain a laminar flow. Of course, this gas going through can be affected by the type of the gas or by the density or the temperature. So we keep this mesh heated. So to first of all to minimize the precipitation of water droplets. So the drop in the pressure between two sides can give a hint of the volume, and of course it can be electronically adjusted to also measure the flow. The fixed principle of measuring the cardiac output is dependable upon the Benedict-Cross, as we said before, method. This method can from the slope of oxygen consumption. Of course, we can expire through this mouthpiece with an absorber to prevent rebreathing. So we can, from this chymograph on the drum, can estimate the oxygen consumption. Suppose it's 250 millimeters per minute, and then knowing the difference with oxygen content and in the arterial by or tank taken arterial sample and in the venous system by tubing through the pulmonary artery, getting a mixed venous pressure content, and then we subtract both. We'll find it will be around 50, as you can see from the figure. This 250 is being divided by 50 to yield the pulmonary blood flow and hence the cardiac output. Now we have what we call the in different or differential effect principle. This is a method which is non-invasive, where we have a special apparatus during ventilation of the patient. This apparatus has a sensor to measure the volume, the flow of air coming out, and also has a sensor to measure the carbon dioxide concentration, so that I can know how much flow of carbon dioxide has been eliminated. I'm sorry. Of course, we can estimate the cardiac output through oxygen consumption or CO2 production. So this system is non-invasive because I can get the blood oxygen sample from the end-tidal CO2 as a comparable measurement, and the volume of carbon dioxide can be estimated through these sensors. It was found that whenever there is rebreathing for around 50 seconds, the mixed venous blood carbon dioxide is not much changed. So we can create two figures of cardiac output. As we can see, these two figures, whenever we rejoin and rearrange, we'll get finally, this is the final results of the equation. Means the flow of the rebreathing of carbon dioxide minus that of normal without rebreathing. I'll tell you what makes the patient rebreathe in such circumstances, and then we in the denominator we will find the arterial oxygen concentration in normal and in rebreathing. I'll tell you later on. So this is the figure. The rebreathing upwards to the right, and the rebreathing the oxygen is on the this is on the left, and the one downwards is on the right, so that you will not be mixed up. I will show you later how does this apparatus work. This is a picture of the Benedict-Cross. Of course, this is drum. This is water seal. It's minimal to minimize the air leak. You see, and this is the chymograph where it draws the slope of oxygen consumption. Of course, the patient must have a special soda lime absorber, and this is the figure to denote the cardiac output or the pulmonary blood flow regarding carbon dioxide uptake. And this is the vitellograph. It's portable, and whenever the patient expires, it is initiated to measure the expired tidal volume. Of course, this the instrument measure minimal amount of volumes, and this is the domestic instrument to measure of the volume. It's made of two compartments, and the pillows, and there is a rod. This rod activates a system where it can measure the volume during inspiration or expiration. This is the right respirometer, and this is the van, and this is the gear system which drags the pointer on the scale, and these are the slits so to make the air circulates. And there is of course a button to return it back. This is the electronic flow meter, and we have two pedals with arms, and this is the van. The van is activated, and there is a source of light emitting diode, and it's been reflected to photocells to measure the volume. This is the rotameter, and this is the slits. You'll be asked why is the importance of the slits, of course, and this is the annular space between which, whenever the bobbin goes upwards, the space around it decreases, so that will minimize the resistance and will the pressure yield the pressure upwards equals that downwards. This is a variable orifice, a constant pressure flow meter, and this sticking effect, as we said before, may be a defect, but we use instead a ball to avoid this sticking. You may be asking why do you use a ball instead of the bobbin. Of course, the problem of the bobbin that you cannot indicate the height, so we take it from the middle of the ball. Of course, the importance of this rotameter is the continuous or the continuous indication of gas flow. Of course, this is a statement also that we can use this instruments in liquid, and we can see from the text what are the uses of it. This is the needle valve, where we have a knob and a spindle, and we have a gland and a gland nut to prevent a leak, and then we have a filter. The point that the speed of air here is above the sound, so the linear velocity is very high, creating a high pressure. This will overcome the resistance from the ventilators or the vaporizers. So this is the importance of this high velocity that exceeds the normal flow laws. And this is how we utilize the case of breaking down of the middle flow meter, which may develop an hypoxic mixture of oxygen and nitric oxide. So these are the methods how to rearrange the flow meters to make the nitric oxide first of all before the oxygen, or we can use another tunnel to administrate oxygen through it to minimize the effect of breaking of the flow meters, or we can use chain linking flow meters or pneumatic mixing valves, so that will assure that the oxygen will be initiated whenever I use nitric oxide. And this is the peak flow meter, where we have the fan, and we have the opening of the slit, and we have, of course, the ratchet that keeps the van in position after the patient expires, and then we have, of course, the button to release to get the instrument to work from the beginning. Of course, as we said, the rotation is opposed by a coil spring, and this is the NEMO tachograph. One of the methods I didn't mention maybe in full detail. I'm sorry. This is the mesh, large mesh to assure laminar flow. and this is a transducer to change the pressure difference, pressure to flow. Of course, you may be asking what's the meaning of transducer. It is a device to change and a signal to another signal, suppose electrical to whatever. This is the measurement of the volume of liquid. Of course, we can use a cylinder. We can use, as is a dripping method. This we call it a gravitational. It depends upon the gravitation. Of course, the drop here begins to send slowly against the rule of the surface tension. But when this drop becomes has a large weight, it will be detached and overcoming the surface tension. So we have a light source and we have a photocells. This can count. This chamber ought to be filled to the third of it so that we have a correct results. These are some points regarding liquid flow measurement. You have the chance to have a look about it. The most important thing is what we call the target infusion. This is a device which has a computerized, has a feedback to maintain the plasma level of any drug. So this is it is some sort of a syringe pump to assure whenever I want to use propofol or remifentanil continuous infusion. So this assures a constant blood level of such drugs by having a feedback mechanism to assure a level. A proper level of the drug in the circulation. We call it a target controlled infusion. And this is the Fick principle. And this Fick principle, as we can see, this is the difference between arterial and venous concentration or content. And this is the flow. This is how, and this is the slope. And this is the consumption of oxygen in 1 minute. And from this figure, we can estimate the cardiac output. Of course, this is the other method to measure the flow of any organ. Have a look. And this is the differential Fick principle. These are the sensors, the flow sensor, and this is the carbon dioxide sensor. So you can estimate the flow of carbon dioxide from these both instruments. This is a system where I close the expiratory valve to initiate a rebreathing situation. This rebreathing situation is being performed every 3 minutes. As we said before, for 15 seconds, no much change occurs regarding CO2 in the mixed venous blood. So I'm creating two figures. From these figures, I can estimate the cardiac output non-invasively, because this will give me the flow of carbon dioxide, and the end-tidal will give me the arterial comparable arterial carbon dioxide. The shunt equation, of course, we must put in our consideration while perform this method. How can we be assured that it's, or how can we estimate it? Simply, we can know the oxygen concentration going to the patient, and then we can predict the oxygen saturation. Accordingly, we can estimate how much shunt is present. And this is the pitted tube. The pitted tube simply has a differential pressure transducer. Of course, this is the flow coming from this side going to this side. So different the pressure on this tube will be more than that. Creating a figure knowing that the velocity will be will affect the pressure. And from this equation, I can denote the volume or the flow of the fluid going through. This is being used in the airplanes to measure the speed of the planes. This is the pitted tubes. There is a special adapter to assure that of course this device can be inaccurate, because we are working on a large area. So we use a point to assure that this velocity is correlated to the flow by a special adapter. You can see from the written text hint about what I am saying. This adapter. This is the electronic mass flow meter. All these are measurements of flow, especially you have a gas flow going through, and we have a thermistor. This thermistor been electrified to create heat. If you have 2-1, this first of one measures the temperature of the flow gas going through, and then this one measures how much. Of course, when the gas goes through, it takes heat. So this one measures how much electrical current is needed to regain the temperature of the thermistor after the gas has taken heat from this thermos. I hope that I succeeded. All these are questions you ought to put in your mind and give reasons for all the items present. I'm doing as much as I can to help my young colleagues to accomplish their oral examination. Wassalamu alaikum wa rahmatullah wa barakatuh.